Good afternoon, everyone. We are really glad to have you here today for the Youth STEM Business Conference, specifically focused on the field of engineering. My name is Daniel Burson, and I'm one of the co-founders of the Youth STEM Conference. And we have Jeffrey as well. Jeffrey, would you like to take over?
Hello, I'm Jeffrey. I'm also one of the co-founders of Youth STEM Business. And Daniel and I have been working for a long time. At first, we worked at Student Senate, and we decided to create this opportunity for students across Ottawa. Okay. So
today, please continue, Jeffrey. My bad.
Oh, yeah, no. So to start, what is STEM? The reason why we started this was, of course, Daniel and I wanted to create opportunities for students all over. And STEM it's really an approach to learning that includes mainly the four disciplines: science, technology, engineering, and math. And you might hear it as SMET or STEAM, but essentially through STEM, we hope to give you guys a way to develop key skills like problem solving, stuff like that through STEM.
So I'll talk a little bit about who we are. So first of all, we are located in Ottawa specifically. And we try to target teens, students, and youth in the Ottawa community, specifically in high schools, to learn about different opportunities in the STEM field. We hope to provide adaptive, effective, and engaging conferences for youth to learn about the different opportunities available to them in STEM. Now Jeffrey will speak a little bit about our purpose and our mission for today.
So our purpose here is to give secondary students a way to really look into STEM. Students who don't know what STEM is, who don't know what they want to do, maybe something you don't know what to do, what you're going to do in university, or just find out, there's cool opportunities here and there. And by having conferences providing resources, we can hopefully have you engage in things like understanding a broader view of what things are in your university opportunities. And Daniel will continue with our mission.
So one of our key things for our mission was to provide youth with the opportunities that they would not otherwise have because of COVID-19. COVID-19 has caused lots of problems for universities and schools to provide effective means to teach youth about opportunities after secondary education. So with this conference and with the conferences we'll be running in the future, we hope to enlighten youth about the various opportunities available in the different STEM fields, and as well key aspects for application for universities and different opportunities in their own communities. So our mission really is to provide youth with an engaging opportunity to learn about the various opportunities in STEM. And we're going to now move on to our speakers. So our first speaker today is Huang. He's a second-year computer science student at the University of Waterloo. So we give the stage to him.
Hi everyone, nice to meet you. Glad to be here. I'm Michael. As I was introduced, I'm currently studying computer science at the University of Waterloo. I was told that this would be a Q&A session, but I guess I'll give a brief kind of background on what computer science is. So computer science is basically a field in STEM which primarily focuses on the study of computers, like as the name suggests. So it studies computers as well as how computers work, along with very heavy mathematical, it has a lot of mathematical background and a lot of mathematical foundations. So computer science, you don't go directly into programming. It's not like you just learn about how the computer works, like transistors. You don't go straight into that. In the first few years, you learn a lot of math, you learn algebra, you learn calculus, fundamentals of logic, and then only later do you actually specialize in more things you'd actually associate with computers, like artificial intelligence, neural networks, cybersecurity. Yeah, those kind of things are learned later in the program, like maybe third or fourth year, but at the start, it's mostly just general programming knowledge, along with like most math things, such as statistics, calculus, algebra, yeah, as I stated. So yeah, any questions about computer science in general, or possibly more specific questions about Waterloo's computer science program?
So we do have some questions here from some of the students who would like to know. The first one is it necessary to apply for Waterloo CS if you don't know how to code? So do you need to know how to code to be able to apply, or is that something you can learn when you get there?
So the thing is about most university like programs, they assume no prior knowledge like in programming. So computer science, what they care more about, like anything in Waterloo's math department, so like math, geomatics, pure math, computer science, they all care more about like math background. So things that they care a lot about are performance on, for example, the Euclid contest, the Hypatia, like, so, you know, the mathematical contest that Waterloo hands out every year. So the Euclid is held in April. The other ones for grades 11 and below held in February, I believe. So these are contests that will specifically be asked for on the AIF, which is the admissions information form, which will be basically the supplement to your application to the university and for your program. So no, coding is not a prerequisite. You don't have to particularly know how to code. And yeah, so knowing how to code is nice because they also ask for your performance on the CCC, which is the Canadian Computing Competition, which is also held in February, which is basically an algorithms competition. So yeah, so coding is not a prerequisite, but it is nice to have. So if you have like any experience with coding, then you can definitely put that on your application, as well as the scope of it, how long you've been coding for, etc.
Thank you, Michael. Another question that we prepared for you is, what is the difference between computer science and software engineering?
So as programs, software engineering is a lot more on the engineering side of computers, like is how I'd say it. So I'm not sure about other schools, but at Waterloo specifically, software engineering has to learn a lot more engineering sided classes. Like, so they have to take physics and chemistry, while computer science students have to take more math heavy courses. However, software engineering students also take those math heavy courses. So it's kind of like, actually, it's easier to describe it like this. So you have the math department and the engineering department, and the software engineering students sit somewhere in between. So they learn both from the math side and from the engineering side. So they have to take math courses like algebra, linear algebra, calculus, but they also have to take engineering courses like physics and chemistry. So that's what I would say the primary difference is. Another difference, like in particular, is that computer science students have a lot more free time. This might be specific to Waterloo, but engineering students are known to have like really compressed schedules, so they have to go to class from like 8 to 5 every day, whereas computer science students only have like maybe 3 to 4 classes every day at most. Other main differences is probably how flexible the programs are. So computer science students have a lot more flexibility in choosing electives. For example, engineering students get basically no electives, I think, for the first 2 to 3 years. And only after that can they really choose where they want to go with their foundations from those years. So there's a few questions in the chat. So how did you improve at competitive programming enough to get to the CCO, like DMOD or what? So more background on this. The CCO is the Canadian Computing Olympiad, which is the stage after the CCC, which is the Canadian Computing Competition. So the CCO is an invite-only kind of workshop that's held at the University of Waterloo for the top 20 or so participants on the CCC. So yeah, so every year students write the CCC, and if you do well enough, you get invited to the CCO. So I participated in the CCO in 2018, and the way I prepared for it was, yes, DModge. So DModge is an online judge, which is basically, it's just a website where problems are hosted, and then you submit a solution to a problem, and the judge gives you feedback on whether your solution is correct or not. So it's basically just like an online interaction environment where you can receive real-time feedback on your programming solutions. So basically, I just grinded that out for maybe 6 months from July till the February of the competition. So there's other ways to learn competitive programming. For example, in Toronto specifically, there's a lot of extracurricular classes where you can learn competitive programming, like Olympiad School, Triway Education, Ivy Global. I don't know if such things exist in Ottawa. I do recall there's a program at Carleton regarding computer science and contest programming, but I'm not sure how effective it is. I know their math program's pretty good. Like their math contest class is pretty good. Not sure about the computer science one. Yeah, basically you can probably get pretty far just with self-study and just like trying to figure out what to do on your own. That's what I did, and it worked. But competition is getting harder.
And there is one more question.
Henry asks,
if you would like, please feel free to pick whichever one you would like.
I only have access to the ones like in public chat. So if you've got some like,
oh no, we have we all have the public chat as well.
Okay. So Henry says, other than final marks, what other things do they look for during admissions? So AIF has several categories. It probably changes year to year, but hold on, I'm trying to remember. So there's a page specifically for contest accomplishments. So your performance on all the math contests and computing contests that you can think of. They have a page for grades, which is, the final grades they look for. Also, they might look at intermediate grades if they don't have enough. So they look at your midterm marks. And lastly, there's some like writing components in the AIF where you talk about why you want to be in the program. There might be something about why you started programming, but that might be from the software engineering application since it was lumped together. There's also a section about programming experience and how long you've been programming for, what languages you're acquainted with. There's also probably some other like, template application questions like, I don't know, what's your greatest challenge? What are you most proud of? What's your greatest accomplishment? Of course, this varies year to year, but you should expect some questions of that, and there's that form or of that manner.
And some students are also asking, because of COVID, they're not able to do the Euclid's exam. And I know that was one of the things that you said are important for that application. What opportunities are there for them to do instead? Or is there a way for them to do a test online or somewhere else?
Actually, I'm not too well versed in this. Like, I'm not actually sure how it's going to be handled. To my knowledge, did they say that the Euclid wouldn't be held at all, or it would only be like held through specified proctors? Because if it's not held at all, then there's no chance of writing it.
I believe our school board is not going to be holding it this year. So we're not sure about other school boards, but students would not be able to write that test in school as they would normally do in a regular school year.
Oh, yeah, okay. That poses quite a big problem then, because I think I heard somewhere that Euclid is only allowed to be written via your school this year. So in the past, you'd be able to write the Euclid via extracurricular programs. So like people could write at Carleton, for example, like if they're in a Carleton math class, then it would be supported there. But I think that's not allowed this year, or at least that's what I heard. So in that case, you might actually just be out of luck, since, yeah, if it's just not available, there's not much you can do about it, sadly. In that case, you might want to look into other math competitions, like the, I don't know, CSMC maybe, COMC. Those might have already passed, actually. So if you didn't write those, then that's kind of tough too.
Well, we really appreciate you taking your time to speak to us about computer science and about your journey. And we thank you. Jeffrey?
Thank you, Mr. Michael Huang. Our next speaker is a second-year mechanical engineering student at the Carleton University, Mr. Basarab. Welcome.
Hi, thank you for having me. Thank you for the introduction. As he mentioned, I am Mykolay Basarab. I am in a second year at Carleton University in mechanical engineering. Some things I should mention, how I got there to begin with. I guess in high school, I was really into CAD and physics. So I felt that mechanical engineering was the perfect fit for that. For example, mechanical engineering is the study of material science and the mechanics of certain mechanical systems. And I wanted to see how that would go from there. You can't go wrong with engineering. And some current advice that I can give you all once you pick an any engineering stream for that matter, is that, of course, I all believe that you are all studious, because once you begin to stop studying or keeping track of things, you will fall behind and school become almost impossible to catch up at that level. So you need to be diligent and studious. And one main thing, especially during these times, because everything's online now. So just to make friends and meet new people, which is essentially your network, if you think about it, has become very difficult. So try to join any clubs that you can that's related to your stream. For example, in the mechanical engineering stream, there's the Formula One race car team in Carleton. So they can teach you all sorts so they can teach you welding if you want to go into more mechanical applied stream into that, add to that team. If you're more into software, you can design the software used for the car. If you're more into systems and engine outputs and like understanding the flow, then you would work on the engine with the more senior years of or grads in that team. And like a day-to-day, just like Michael Huang mentioned, that it's basically 8:30 to 4 every day, depending on your schedule. For me, first year, because they decided the way my schedule would go, I would come at school at 8:30, then leave at 9. That's just the way things were. So engineering is a stream that you dedicate your life to in a way. So you got to make sure you pick it right.
So would you say that one question that somebody had is how stressful the workload is? And in addition, someone else had this question, is this a competitive program?
Engineering is one of the most competitive programs out there. Every 4 years, they changed the curriculum because of this, because every year, I was one of the last years in a set program. And then right after us, they changed the format because everything just changed, because we need more programming now, because that's just the future at this point. So software engineers have it well. But in terms of stress, I've learned how to efficiently find outlets to de-stress after certain exams or midterms. So if you can pick up a hobby, exercise is actually really good. It helps you keep a fit mind and body state. And it's a good form and healthy form of de-stressing yourself. So it's something you have to consider, the stress.
And another question we have is, what made you choose the field of mechanical engineering specifically?
Well, at school, I didn't really have an exact idea or plan, oh, I want to become this, right? Mechanical engineering is such a vague branch, and it's a bit more general. And later on during the years, if you pick something you like, you can focus more on that in your later years in third or fourth year. So I enjoyed CAD That was in high school for me. Physics and math, they worked pretty well for me. So mechanical engineering was the logical choice.
And
Would
you do any co-ops? And if you did, do you have any tips and about doing that?
Well, I'm in second year right now. So right now I'm taking the course for co-op that prepares you in choosing your co-op job. So in mechanical engineering, in Carleton specifically, once you get into the program, you'll have a co-op course and you'll have a set schedule on when you can have work terms and study terms. For my course, I'll have my work terms during the summer. So some tips I can tell you would be that learn people skills. It's really helpful. Learn to speak, not really small talk in a way, but learn to be comfortable with people. Surround yourself with like-minded people. That will be your network, your group of friends at school or your study group. That will be your network. So that's when people say choose the right friends or choose the right classmates. That's basically what they're talking about.
Well, for those who are interested in mechanical engineering at Carleton, what are some courses you'll have to take in high school?
In high school, well, the main courses you'll have to take is definitely physics, both calculus and advanced functions, chemistry, because mechanical engineering is material science based as well, and programming will be helpful to know. You'll need to take limited, but there will be some programming courses in university for you.
So another question for you is, how well does this program at Carleton apply to the industry?
That I'll have to see for later because once I get to my co-op, but Carleton, from what I've seen, is a school, they have good connections, especially in their co-op program. Carleton has one of the best co-op programs, I believe. They have many connections in the Ottawa region, and especially for engineering students. So we'll have to see at that point. But for the labs, from what I've seen, they tend to focus more on the applied practice, which is what you want in an engineering field.
One question from the comments, what's your favorite programming language and why? I think that'll be our last question.
Our last question, all right. Well, from the programming languages I've learned, I would say that the most memorable and at that end, favorite programming language would be Python. Python is a very simple language, but at the same time, it has this, you build this relationship with it in a way. It's so simple and beautiful at the core, but can be excruciating just to fix at times. So, and that will be your first year programming course in Carleton. If you take mechanical engineering, it will be Python.
Thank you very much, Mr. Basarab. We definitely appreciate you coming and talking to us. And Daniel?
Well, thank you so much. And I guess it's time to introduce our next speaker, Anthony Massaad. He's a second-year mechanical engineer at Carleton University as well.
I think they're a bit wrong. I'm a software engineer.
Oh, well, software
Yeah,
engineer. Well, I apologize for that.
It's all
mechanical.
Good. Like Mykolay, I go to Carleton. I'm a second year. I'm a software engineer. Other than that, as a software engineer, you learn more about like how to build type of projects and code more often. Though like Myko, during your first year, most engineers will be taking the same courses, just because if you want to switch out the programs, you can you're more free to switch out to different streams after first year. So like you'll be able to get the option to become electrical, civil, software, mechanical, and all that type of such. But as you move closer to the end of your years, you get to build onto the main stream you chose. For example, by fourth year as a software engineer, I'm destined to build like a project during my first and second semester. Other than that, really, there's not much big difference to what Myko said compared to what I would say, since every engineering stream will have the same basis. The workload is pretty heavy. you will have to put a lot more effort compared to other type of programs. But other than that, it's good to get the mindset to like understand priorities and time management. For example, it's okay to skip classes as long as you're able to maintain and still keep up with your overall expectations. Because it's important to just set priorities and to just keep going forward on like if you know you're going to fail one class, you're going to put more time into that class than other classes. And so you're going to probably skip some classes to study more for this one class because you have this big important test coming up. But you can always catch up because everything, no matter what, their lectures, they sometimes record their lectures, and you even have YouTube, Google, and other type of sources you can actually rely on. And the most important thing is investment, okay? I personally invested in Chegg during my first year, which helped me so damn much in all my courses because they have textbook solutions. They have you can ask questions, and you can always find answers on Chegg. And sometimes it's helpful to get like to see a solution to something than trying to figure out yourself sometimes, because sometimes you can't, you're stuck and you just get demotivated and you just procrastinate, right?
Would we be able to ask you to write that in the chat, the Chegg, for people who don't know how to spell that?
Chegg, literally just Chegg. It's about 20 something bucks a month, and it's probably the best investment I ever have. I still have it to this day. It's a really good use. Sometimes I ask questions all the time on there. I get expert answers, and sometimes they're wrong. Don't get me wrong, right? Not every answer you're gonna see is right, but you always get that vision being like, okay, this is the approach that I need to take. And even if it's wrong, you'll always get to a point where like, okay, I can figure this out now.
And I know you spoke about in your program, you actually get to design things and actually put some things into play. Could we
Later on, yeah.
Later on.
So similar to what I believe Michael was it that the first, similar to that, during your first couple of years they set a foundation for you.
Okay.
That as you get towards fourth year, you get into your stream. So you get to program, you get to do anything that deals with what your stream is based on. But up to that point, you kind of just build like you just build a foundation of different type of engineering, maths, and all that type of such. You program over time as well, but by fourth year, you're into that stream. But I'm not sure with other engineering. I know with my engineering, my stream at least, as I go up as a software engineer, we also take some electrical courses. Just because by fourth year, you get to choose two type of big projects. You get to choose a big programming project or a big electrical project. And it kind of relates a little bit with electrical and software engineering, just mostly because software and then electrical kind of relates, and so it is fine for that. Other than that, the main difference between a computer science and software engineering, like Michael said, was that whole programming and building type situation. So more of a software engineer, you're more likely to build a project and the foundation of a project and kind of test code and stuff like that, while the computer science person codes the project, he programs more. So if you're not really into programming as much as you expect, but you like math and programming anyways, you can take the software engineering stream. But if you're really into programming, you want to program more, the computer science is the way to go.
And one of the questions we have here is people want to know, what extracurricular activities were you part of in high school, and how do you think they helped you decide where you wanted to go?
Fun fact, I did not join much extracurricular activities. The only major thing I would ever attend was like during lunchtime or during the morning time or even after school. I'll go to my computer science class for grade 11 and 12 and just program there because I just thoroughly enjoyed programming at the time. It was pretty fun. Even now, I actually enjoy programming. During the summertime, I programmed a couple things that was pretty fun to do. Other than that, to get into Carleton, it's more or less just grades. It's not like anything, you don't need anything special like Waterloo or University of Toronto, just because they don't look at that type of stuff. I find it stupid how they kind of look at things, but it is what it is. It's just how the whole like society is based on. It's just marks. But really, if you're in university, if you're going to university, I wouldn't think about marks too much, just because no matter what, you'll graduate and you'll get a job. They don't look at what did you get in your second year of math course. No, man. They just say you're an engineer. Okay, what type of engineer? Okay, are you familiar with these? Okay, then you're hired. It's just that type of base. It's not really, there's nothing important. What type of projects did you build in software engineering? So, so Henry, you asked about what type of project you built in software engineering. So in first year, they give you the basis of Python, just because Python is the most basic type of programming language to learn. And if you know how to program in Python, every other language will be probably very easy to learn, just because the only major difference is syntax. In software engineering, so since I only did first year, you will, in first year, every year is a bit different, but in my first year, you built some sort of photo altering software where you would put in a photo, and depending on the function you put the photo in, it'll kind of alter its colors and how the image looks and all that type of stuff. Think about it as like a second Photoshop, but a pretty crappy one. But it was still pretty fun to do, just because you get to learn a bunch of things about Python and introduction to Python. So that's not, so technically you don't need a prerequisite in computer science. All you need to know is what programming is. And in high school, I do recommend, well, to get into engineering, I do recommend taking a lots of math and physics and chemistry, just because those type of things are needed as prerequisites. Plus, they're going to be the most helpful things to know as you move up into an engineering stream.
Can we just ask how chemistry relates to engineering directly?
How does chemistry relate to engineering? I'm not too sure myself, to be honest with you. The thing is, okay, so chemistry, every engineering type course in the first year will take chemistry in their first year, just because it's just a science. It's good to know, especially if you're moving more to an environmental biological type of engineering stream. So it is good to have that type of knowledge about chemistry, because organic chemistry, right? Everything is about organic chemistry, can relate to environment and your human body and your anatomy and all that type of stuff. So it's really good to have chemistry. And yes, like that person said, because chemistry is based off chemical engineering, it does help out. So chemistry is needed to go into the engineering stream for sure. But technically, they only recommended two type of sciences. So you can take biology and physics and still get into engineering, and still take chemistry in first year. Because the chemistry in first year is more based on the chemistry from grade 12, but a little bit advanced. It's nothing like serious.
That's very good to know for students, that they can take any of the three sciences to get in.
Yeah, it's not, they're not stressed about it. They don't really stress too much about what type of sciences you take, as long as you take two at least, just because by first year you'll be knowledgeable in many type of sciences, and if you're not knowledgeable in one, you'll still have to learn it eventually.
Definitely. Well, thank you.
Is there anything else you want to ask me, or?
I think we appreciate you taking your time to explain to us about software engineering.
The program
I think it was helpful for a lot of students. Guys, Chegg, remember that? Good study tip for people in the future.
Mike had a question. You might
please.
have already said this, but with knowing how to program prior to your undergraduate study, important, and can you start with little to no knowledge about programming? Yes, you can, because no matter what, in first year of engineering, you will be taking a programming course. If you're going into mechanical or electrical or software, you are required to take a programming course. And they don't give you that like hard of a programming course technically. Python is, again, the most simple program to learn, just because its syntax is very easy. It's a very easy based programming language, and everything builds off that foundation.
Okay, thank you very much, Mr. Massaad. So our next speaker is Amos Yu. Unfortunately, he is not going to be with us at this meeting right now. So, but he's recorded a very nice video clip for us to watch, and we'll be posting this on Instagram, on IGTV, and you'll be able to ask questions in the comments below.
Hey everyone, I'll quickly introduce myself. My name's Amos. I am a third-year mechatronics engineering co-op student at McMaster University. And I'm very excited to be at the STEM conference for you, making this video for you. I'm very excited to talk about what mechatronics is, how it relates to STEM, my experience as a university student, and hopefully you guys can get something out of this presentation. So let's quickly first just talk about what mechatronics is. Given that you guys are into STEM, I'm sure that you guys already sort of understand what something like electrical engineering would be, or say computer engineering, but mechatronics is pretty new, so I'd like to quickly go over it. So the way I would describe mechatronics is sort of like a combination of a lot of different types of engineering. So imagine that you take like a quarter of mechanical engineering, a quarter of electrical engineering, a quarter of software engineering, and a quarter of systems design engineering. Put those all together, and that's mechatronics. Now, I'm not saying that mechatronics will take over the entire engineering industry. In industry, we definitely need people who specialize in mechanical, right? Like people who are really good at mechanical, people who are really good at electrical. Like mechatronics is not here to replace them. Instead, what a mechatronics engineer would do is, help these people who are very specialized in these different fields and help them bring everything together to make a unified product. For example, like a car, which has both mechanical aspects, like the engine, and also electrical aspects like the dashboard for the driver, the radio, etc. So that is just a quick overview of what mechatronics is. I guess the next thing to talk about is sort of my university path so far. So I did mention that I'm going to McMaster University. I attend as an engineering student, and I also mentioned that I'm in the co-op program. Now, quickly, the difference between the engineering co-op program and just the regular engineering program is that if you're in the co-op program, you need to have accumulated 12 months of real-world work experience by the time you graduate. So this work experience could come from, say, like a big company or a startup, pretty much anywhere that McMaster approves. And if you manage to get those 12 months accumulated by the time you graduate, then your degree will pretty much have the word co-op at the end. So in my case, it would be like mechatronics engineering co-op. So before I share about my experience as a mechatronics engineering co-op student at McMaster University, let's just quickly go over what it would look like for you or anybody else to be a co-op student here. So I guess the first thing that is different about Mac compared to other universities like Waterloo and U of T is that the first year is general. So you wouldn't actually specialize until after first year, and while you're in first year, you'd learn like general chemistry, general physics, general mathematics, or like general engineering design, right? And it's not until second year where you would specialize into the preferred stream of engineering that you want to go into, for example, civil or chemical engineering. And in second year, this is really where the differences show in between the different pathways. For example, if you become a software engineering student, you would learn discrete mathematics, which is not something you would learn if you, say, specialize in computer engineering. And vice versa, right? If you go into computer engineering, you would learn advanced calculus, which is not something that you would need as a software engineering student. In terms of how the co-op aspect comes in, most people will just find a 12-month internship after third year because that's usually the easiest time to find a co-op, and also they just get the whole 12 months out of the way in one go with one company. But it's totally up to you how you want to distribute those 12 months. Like you can do what most people do and just do the 12 months after third year, or you can split it up in 3 sections of 4 months and sort of distribute those for all the summers. And if you do that, like just take that for example, if you do that, you can be done your entire university career in 4 years with a co-op degree. If you do the thing that most people do, you'll be done in 5 years because you would have done 3 years of school, a year of co-op, and then you come back for your last year. So in terms of my path, it starts off like any other frosh. All I remember is that in high school, I really wanted to do mechatronics. So in first year, I just did the general year, and by the time I got to second year, I just, went along I went forward with what I already decided I was going to do, and I just specialized in mechatronics engineering. In terms of co-op, I was actually very fortunate. This past summer, I'm in third year now, so we're talking about the summer after second year. I actually managed to land a 4-month co-op at BlackBerry, so that got 4 months out of my way. And given that I'm in third year right now, it's sort of expected that next year I would take that year off that I talked about. And currently, I have found a position. I'll be working at AMD next year for 12 months. And that's sort of where I stand right now. In terms of academics, you can sort of expect to spend around 25 hours every week in class. So that could be lecture, tutorial, or a lab, which is like hands-on, pretty hands-on. And these sorts of classes, as a mechatronics engineer, like all my classes are related in some way to STEM. For example, we got like thermodynamics or signal processing or like embedded system design. I know those probably don't mean a lot to you, and they might even be scary, complicated to some of you, but trust me, by the time you get to third year, it'll be pretty commonplace to hear like these terms, and you will be prepared for it, so just don't stress. And outside of class, outside of those 25 hours, you could sort of expect to spend a few more hours every week just studying for those classes, doing assignments, and prepping for midterms. While on the topic of midterms and assignments, I'll just quickly talk about what that experience is like as a university student. It's a lot more different than high school because, first of all, in university, participation does not matter. You're in a lecture hall with like a few hundred other students, so there's really no realistic way for the professor to give participation marks. You'll notice that in first year, the sum total of your assignments will be almost pretty much around the same weight as your midterms in regard to your final mark. So for example, all the assignments for the whole year would be worth like 30%, and then your 2 midterms would be worth 15% each, so that's another 30, and then your final exam would be worth 40. So that's sort of what it would look like in first year, but after going into second year, and especially by the time you're in the third year, assignments will either be worth very little marks or they'll just be completely optional. And most of the marks will be in the 2 midterms, 2 or 3 midterms during the year, and the final exam. So you might sort of think that, having less assignments in second and third year is great because, there's less work. But the thing that's really paradoxical about it is that assignments are actually helpful. Since there's so many assignments during the year and they're worth so little, it really doesn't hurt you if you do poorly on one assignment. And it helps you, build up your mark in smaller steps, which is usually safer. And also just having assignments dispersed throughout the whole semester just helps you, stay on top of the course, and it really pushes you and doesn't really let you fall behind, which is really good. But in second and third year, when there's no assignments and midterms are worth everything, midterms and the final are worth everything, a lot of the motivation and the studying has to come from yourself. You have to be self-motivated. So I guess I'll just end this presentation off with one last, tip for you guys. If you didn't get anything else from the presentation so far, that's totally okay. I think this is the most important part. I would just encourage you guys to be good for yourself. Now that might sound kind of weird, but I really want you guys to consider what do you love doing and what are you good at? Because the last thing I want for you guys to be doing is to be in a situation where you're in university or you're in college or an apprenticeship or wherever you decide to take your post-secondary career and you really don't enjoy what you do, and that you're also unaware of what you're good at and what you're not good at. So I'd really encourage you, be good for yourself and know for yourself what you love to do and also what you're good at. Because I really want you to enjoy your post-secondary time. And if you do something that you're good at but that you don't love, well, you're gonna be spending 25 plus hours a week doing something that you don't want to do, right? And if you don't love it and you're not good at it, well, I'm sure you can probably tell you're pretty much setting yourself up for a bad time. And I think this piece of advice is so helpful because it covers so many other, pieces of advice that I could have given you, but it's in, such a small package. Because if you're good for yourself and you're good to yourself, you'll care about your success, right? You'll care about where your life is headed. You'll care about your future. And with that comes pretty much all the other good things. For example, if you care about your success, attending lecture will just come naturally to you. Motivation to study hard will just come naturally to you. In your free time, you'll actually want to put additional effort into what you're learning. You'll be excited when exploring things that you're actually interested in, and that will all come naturally, if you care about your success and if you're doing something that you love. So I guess that's everything I had to say. Yeah, I know that my presentation really didn't have a cohesive theme. I just really wanted to share with you what it's like to be a student in STEM and hopefully help you discern whether this is something that you'd want to get into. So I think that's all the time that I have. Thank you for listening.
And that was Amos, third year mechatronics at McMaster University. Just a quick reminder to those who have arrived a little late. We are recording this meeting, so if you're not comfortable, just turn off your webcam or mute your microphone. Daniel?
Now, before we move on, there's a couple of questions we have in the chat, 2 or 3. Maybe any of the students would be willing to answer them. The first one is there English or biology class in first year engineering programs?
Not necessarily English or biology, no.
Yeah, maybe
Carlton, at least you'd pick 2 electives.
I could add something there, guys, if you want to. Yeah, it depends and varies, right? If you are doing a biotechnology related engineering, biomedical engineering or something, you would end up having a biology program. And in all universities, you would have a technical writing program. It's not technically English, but there might be a technical writing course that you would take, a communications related plus technical writing type of course that you would take. And that's a language course that would be done outside of the Faculty of Engineering. So it's probably done by the people in English, but it's not an English class. It's a writing / communications class. Okay.
Thank you so much. Jeffrey would like to introduce the professor.
Yeah, sure. As we have discussed, we will of course have our professor speaker from Carleton University, Civil and Environmental Engineering Professor, Mr.
Siva. Sivathalayan. Siva is good.
Siva.
Okay, guys. Yes. So I just made a small PowerPoint. That's why if you can let me share it, I'll just put it out there and then we can go from there.
So you should be able to share your screen at the moment.
Oh, I should be, okay.
There is a button at the bottom of your screen.
Yes. So you guys got it? Okay, I'm sharing it right now, right? Okay.
Perfect, thank you.
Okay, thanks guys. So I am a civil engineer. So I thought I'll talk about civil engineering. I mean, say a couple of words about who I am and then talk about civil engineering and tell you what sort of civil engineering is and what we do in civil engineering. And there's a little bit of difference between a typical civil engineer versus a civil engineering professor. Right? Engineers work in design and construction. Professors, we do research and teaching. And most of us are still always involved in design and construction as well. So I did my schooling and my bachelor's degree in Sri Lanka. So when I got a bachelor's degree, I was a civil engineer. Then I came to Canada, to UBC, to do my graduate studies. And in graduate studies, I kind of moved to a narrower field of civil engineering. From being a civil engineer, I then became a geotechnical engineer. That's a specialized field in civil engineering. And I worked for a short while as a geotechnical engineer. And then I joined Carleton as a civil engineering professor. So once I became a professor and once I started focusing on research, my area became narrower again. So from being a civil engineer to a geotechnical engineer, now I specialize on what we call geotechnical earthquake engineering. We try to look at how earthquakes cause damage and then try to address them. So the reason I sort of listed every one of them is that as you go up and become a specialist, you end up potentially looking at narrower and narrower fields. That's how you really become an expert in that area. So I do teach engineering. At the first year level, I teach all engineering students. Doesn't matter whether you are civil, mechanical, electrical, or whatever it is. I teach all of them. And then I teach our specialist students in fourth year, and I do have teaching graduate courses. So when we say civil engineering, you probably have heard about it, but there are many specialties in civil engineering. Each of them could be a branch of its own. Right? But the thing that we need to realize, we don't at times think about it, is our day-to-day life depends very much on civil engineering systems. The houses, buildings we live in, the roads and bridges we cross, the water that comes into your home, the wastewater that gets out, those electricity lines, gas pipelines, and the internet and TV cables, or even the cell phone towers, they are all put up there by the civil engineers. And the air that we breathe, the quality of that is controlled by environmental engineers, which is the broader group of civil engineering. And we also work a lot in mining and resource industry, right? Be it oil and gas or metals and minerals. The extraction of those resources is very much a part of geotechnical engineering. So given the broader scope of things, I thought instead of talking about every one of them, I'll just throw away some photos so that you will recognize what you see there. These are all the kind of stuff that you see out there that are done by civil engineers. Now, on the right-hand side, those three ancient structures, they are there to sort of tell us this has been going on for a long time. We have been building things for a long time. The pyramids and the top structure is actually very, very precise design. The aqueduct built by the Romans, done about 3,000 years ago, it was very nicely done. Okay, very, very precise building. Okay. And then you have got bridges, dams, and we also do artificial islands or man-made islands, and then reclaim land if you are short of land. So one of the photos that you see here, the bottom row, second diagram, that was an artificial island built in Japan to build an airport. So they didn't have land, so we build an island, then we build an airport on it. That's a part of civil engineering, which is called geotechnical engineering plus structural engineering. Now, whatever the things that you see there, that's what's above ground. There's a whole bunch of things that's beneath the ground that you don't see, but that's equally important, part of civil engineering. Okay. So it could be, the first thing that comes to mind would be foundation. Everything that we have has to have a foundation. Okay. Or it could be tunnels, or it could be pipelines. It could be things that carry your cables around. Your internet signal, your telephone line comes into the house through a conduit that goes underground, which is part of civil engineering called trenchless technologies. We use them to install those lines. And the two steel cages that you see there on the right-hand side top diagram, that's about 8 to 10 feet wide, 50 meters deep. That goes into beneath the buildings that you see up there. So each of those huge structures, which are probably several meters wide, tens of meters deep, they are hidden beneath the structure that you see above ground. So civil engineering is both what we see above ground plus what we don't see, that is below ground. Now, within all of this different disciplines in civil engineering, I specialize in geotechnical engineering. So what we do as geotechnical engineers, we design dams, foundations, retaining walls. Dams could be for hydroelectric power or for storing tailings. I mean, the oil sands facilities, they have some of the largest dams in the world, right? And the whole idea behind geotechnical engineering is that we want to make sure the soils would support the load without extra deformation or failure. And we want that to happen under normal situations, day-to-day operation, and we want that to happen under extreme loading events, say such as earthquakes. Now you need to recognize, here we are talking about soils as an engineering material. That's pretty challenging and difficult because soils are not like other materials. We don't get to choose the soil that you get in your site. You have to go and work with it. Okay? If you are building something with steel, concrete, you can order them. You can tell them, I want this kind of steel or I want this kind of concrete. So we sort of joke about it. Soils are like family. You live with them. You get what you get. Other materials are like friends. You are allowed to choose them. You can move on to better friends, or you can keep your current friends, right? You can, if you are happy with the material that you get, you work with it, or you get a new material. We don't get to choose that in soils. Now, as a geotechnical engineer, my work very much relied upon in using computers. Our analysis and design are sophisticated computer programs. We use techniques called finite elements or finite difference. These are numerical techniques you would study about in the university. So there are sophisticated programs that are required to handle those things. And on the other side, if you are working in research, I do laboratory work. We have data acquisition and control that requires lots of electronics and hardware interfaces to connect to the equipment. Right? And as I said earlier, our work is mostly hidden. By our, I mean geotechnical engineers' work mostly hidden. But if we do it right, we are not even going to think about it. The building is going to be fine. You don't need to worry about the foundation. But at times things are not done right. At times we run into problems. Okay? Those are the things that we want to learn and fix. That's where research comes in. We are saying in our discipline that anything that doesn't have a good foundation has to fly, float, or fall down. Okay? So I thought I'd sort of show some of the problems that we have had as engineers over the years. Okay? These are different types of failures that have happened around the world. On the left-hand side, the top two, those two happened in Canada. One was in Winnipeg, other one was in BC. Okay? And on the left-hand side, the bottom two figures are what we call tailing dams failures. So these are dams that are storing waste material, and because of poor design, they failed, and then they have run off into the villages or towns underneath. The red stuff that you see at the bottom left-hand corner, that is as toxic as it can get. That's a material with a pH of about 13. I assume you guys know what your pH is. That's very toxic. We wouldn't even want to drop off it near in our labs when we are testing it. We are very careful about those things. But this thing broke a dam and ran into a village and killed people. And when things go wrong, sometimes you are lucky. You don't really have to sort of worry about it, or it doesn't really show up as much. That is what you see on the top diagram, on the top row, third diagram, the thing with the yellow dome. I mean, it doesn't look like there's anything wrong with it. But what it's hard to see there is that the ground floor, which normally is taller than any other floor, looks pretty short there. It looks pretty short because this building has sunk into the ground by 15 feet. That's about 4.5 meters. Okay. So where it was originally, it has sunk in by about 4.5 meters. Same thing with the Leaning Tower of Pisa. I mean, it tilted and then it stabilized, or then we fixed it, we managed to stabilize it. So technically there was something that went wrong, but that was pretty a good thing for the city. It became a tourist attraction, and these guys are making money off it like nothing, right? So some failures are very problematic. Sometimes they don't show up as well. Depends on how lucky you are. So the failures that you see here happen during day-to-day operations. There's nothing special about that triggered these failures. On the other hand, my research is focusing on earthquakes. So we are going to look at what happens during an earthquake. So there are failures that happen during earthquakes as well. So you remember, an earthquake lasts for a short time, say 30 seconds to a minute. That's all it takes. Okay. that the story of that car that you see there is pretty interesting. That was parked on a road in front of somebody's house. It was just like the street out in front of your house. It was parked on a street. Then the earthquake hits for 30 seconds or 45 seconds, and that's what happens to the car. The street got about a foot worth of sand that came from underground. And then as the sand comes underground, it's coming under high pressure, it created what we call a sand boil, and the car simply sunk into that sand boil. Okay? And these type of problems are happening because of the extra load. So these are extreme events. Okay? So that is where our research comes in. So in research, we are trying to better understand the issues relating to extreme loading events. Okay? The thing to remember here is that earthquakes can be pretty catastrophic. Right? There are earthquakes that have killed 250,000 people or 500,000 people. The 76 Tangshan killed about 500,000 people. The other two killed about 250 to 350,000 people. Once again, remember, these are events that are lasting 20, 30 to 40 seconds. Right? So my research, what I do is to look at how we can better understand issues related to earthquakes, and then how we can improve or how we can mitigate damage that comes out of earthquakes. There are students who work on this, okay? And the good part about being a professor and being in research is that I get to train future engineers. It happens at the undergraduate level. In research, it happens at the graduate level. Grad students come from all over the world, okay? And they are mostly top talent in their countries or in Canada, wherever it is. So among you who go to undergraduate school, who is doing well, you will probably pursue a graduate career. You go to grad school. At grad level, you do your research. That's where you really start trying to come up with solutions to solve the world's problems. So research has different phases. It looks differently in different places. For us in civil engineering, it could be experimental. That could mean you could use some equipment to study the different types of loading. So what you see here is some type of simulation of earthquake loading using an experiment in the laboratory. Or you could do numerical work using computers. So that's the other type of stuff you would see on the other side. But this can be very exciting and interesting because you are really trying to advance the knowledge, and then you are trying to provide solutions to the world's problems, right? I mean, what's better than solving the problems of the world, right? So overall, what I want to sort of say here is that in STEM fields, there are many opportunities. And I was just talking about civil engineering and specifically geotechnical engineering, but there are different openings. And one thing to note is that boundaries are sort of blur between engineering and science and math in research. If you are going to get involved in research, you need to be good in math, you need to have a good background of basics, and you are going to have good engineering background as well. So when you look to decide where do you want to go, what you like to do, I hope these kind of thoughts and these illustrations help you sort of at least providing some insights into you. One thing you want to make sure is that you go to a program that in engineering, I'm talking engineering now, if you are going into an engineering program, make sure that's an accredited program. In Canada, we have an accreditation. Any accredited program will give you a sufficient and solid background and would be accepted by everybody and every professional engineering organization in the country, right? So that's all I just want to mention about civil engineering. I'm happy to talk to you guys about this or anything else that if you have questions. Thank you.
Okay, thank you very much, Professor Siva. There are two questions from the chat.
I see them.
You see them?
Yeah, I see them, so I could talk to them, yeah. So the first question is from Basant about, is environmental design a branch of civil engineering, environmental design available at Carleton University? So in Carleton University, we have what we call environmental engineering. And that's part of the, so at Carleton is somewhat special when it comes to environmental engineering. Our environmental engineering is a standalone program. So we have a civil engineering program and an environmental engineering program. They both join as a department. in most universities, environmental engineering would be part of the civil engineering program. There are probably about a handful of universities, about half a dozen, I think 6 to 9 universities in Canada, where you can get an environmental engineering degree in its own. Okay. Otherwise, that will be part of civil engineering. Okay. The same applies to other engineering too, right? I was talking about mining engineering. There are universities where mining would be a separate engineering. UBC is one of them, okay? Or Queen's is another, right? But in other places, the mining skills are taught within civil engineering. Civil engineering is technically an umbrella term that covers many of them, okay? So environmental engineering and design, the big umbrella scheme, is part of civil, but there can be an independent program at different places. So Carleton has a separate environmental engineering, University of Ottawa doesn't. Over there, environmental engineering is part of civil engineering. So next question I am looking at here from Ilham is that I teach all engineering in the beginning. Yes. Oh yes. So in many programs, your first year would be a common core. Not always. In many programs, it would be a common core. Even if it's not a common core, professors teach across departments. So what I teach in first year is basically what we call engineering mechanics that applies to everybody. All students would take it. That's basically physics, and a slightly advanced form of physics. The way I tell my students is that is basically your high school physics. We kind of bring in more math into it and teach it as physics, but from a mathematical perspective. So that's where we want to sort of take the same concept you studied in high school, but mostly done using vectors and calculus. We bring those into your physics to sort of make it, give it the mathematical flavor so that you can go up and start using those things and apply them in computers and so on, right? The whole idea of why mathematics comes into physics is that's so you can expand physics, right? Regardless of any engineering that you want to do, I shouldn't say any, unless you are going into biological or biomedical, those cases, maybe physics isn't as important. For every other engineering, civil, mechanical, even electrical, everything, physics is very important. Physics is a very, very fundamental requirement for any engineering program that we would have, right? So what engineers have to take architectural certification or the similar certification to work? So technically, architecture is a different program, right? So there are architectural engineering programs. Waterloo has one. Carleton has one. We call it differently. We call it sustainable. Well, sorry, our architecture program is called conservation and sustainability engineering. Okay. Or we shorten it as ArcEng, but technically the long name has conservation and sustainability in it, right? But when you are doing an engineering degree, the plan is that you are going to work as an engineer. So you are not going to become an architect. So what happened when I mentioned about the accreditation, about you want to make sure your program is accredited. So once you get a degree from an accredited program, then that would be recognized by all the provinces in Canada. But before you start practicing as an engineer, you get your degree, then you need to get what we call a PEng, a professional engineer certification, right? So if you have an accredited degree, then getting a PEng is very straightforward, okay? But that PEng allows you to practice as an engineer, okay? But if you want to be a professional architect, then you have to get an architecture degree to get a professional architect designation, right? So engineering and architects, they work together, especially civil engineers and architects, we work together all the time. But in terms of working, unless you are in architectural engineering and you want to get more involved in architecture, you don't need a certification in architecture to work as an engineer. But the closest come would be civil and structural engineering. Those would be the closest.
Okay, thank you so much for your very nice presentation and insightful answers for questions.
Thank you, guys. I saw somebody gave me a Nandri. That's Tamil. That's my mother tongue. So I thought, okay. I don't know how to type it in Tamil, but I appreciate seeing this. Okay. Good, guys. Good. Anyway, nice talking to you, and good luck with your future. And I hope you guys choose what. And you are in a special situation here anyway, right? The COVID time. I hope things get better and you guys get to go to your university. because being on campus is a great experience, and you don't want to miss that if you can.
Thank
Okay.
you so much.
Thank
That was
you very much, guys.
great. Thank you for coming.
Nice talking to you. Thank you.
So next we have a little segment about business and how we can apply STEM to many business aspects. So this will be presented by our Daniel as well as Mansi.
So I think Daniel's going to take it away first on the importance of communication, and then I'm going to speak a bit on the importance of networking, and promise we'll keep it short, we'll keep it sweet, and we'll keep it concise. Daniel, you are on mute.
1 minute, guys. Always technical difficulties. Can you guys see my screen?
Yes, Daniel. Looks good.
So hello, everyone. My name is Daniel Bersignou. I'm one of the co-founders of Youth STEM Business Conferences. And today I'm going to be giving you a quick segment on communication. So communication is the key to your success. Whether it's running a business, networking, or managing a team, proper communication is key. One of the most important parts of communication is being clear. You have to know your stuff. When you're speaking to someone and trying to explain something, you have to be knowledgeable on the topic. As well, don't waste their time. You only have 30 seconds to grasp someone's attention, so be clear and be precise. The next most important thing is believing in yourself. Your passion is the driving force. People can feel your energy. It all starts with you. Before you have a team, before you have investors, and before you have clients, you need to believe in yourself, and you need to communicate that passion to others. Now, the third most important thing is being open. Sometimes the most important part about speaking is not actually speaking, it's listening. Listening to learn rather than to respond. I've worked on many projects where I've taken lead on many things, but one of the most valuable things I've learned is listening to others when you're trying to communicate. Everyone has unique and valuable ideas, and together you guys can come up with very magnificent things. Now, always remember, these are the 4 fundamentals to speaking. Number 1, eye contact. It helps build trust. Number 2 is the content, what you're actually trying to say, the message you're trying to convey. Now, 2 of the most important things are tone and confidence. If you're screaming at someone or if you're too soft, no one's going to want to listen to you. You need to have a clear, concise voice that engages your audience. And most of all, you have to be confident. You can fake it until you make it. It's really important that you feel confident in what you're saying and in yourself, because the audience can also feel your energy. Thank you. Next off, we have Mansi. She's going to be presenting a little bit about networking, so I'll stop sharing and I'll let her take on that.
Thank you, Daniel. Raising the standard for me, as always. Can you guys see my screen okay, or is it really, really small? It's really small?
Yeah. You see a sliver.
Okay, let me try one more thing. See, one of the pleasures on being online is you can reach a large group of people, but one of the worst parts is having to mess around with your slideshow on the fly and praying that by the time you end up speaking, it's clear. Is that better?
Yeah. That's good now.
All right, so building onto the fabulous presentation that Daniel just gave, I'm going to be speaking on the importance of networking and using those communication skills. So pay attention, but before I get into anything else, when you're networking, as you are all right now, it's virtually. So what I'm trying to say is I can't see your beautiful faces, but if you're comfortable, I encourage you to turn on your camera so you can make the connections that you're here to make and take full advantage of the wonderful conference that you're in. So that being said, my name is Mansi. I'm a grade 12 student at Sir Robert Borden High School. I'm going to take you very quickly through some of the most time-consuming and, dare I say, important commitments that I'm in and that have given me a substantial amount of experience that I'm honored to share with you today. I won't go everything because in the essence of time, I'll let you read through it. But while you do, if you're a really quick reader, I'm going to ask in the next 15 seconds that you write what networking means to you in the chat. I'm going to try and read through a few answers, see what you guys are feeling. But honestly, I want to see what you guys know. And it's okay because I'm going to mention it in a few slides, but networking is fluid. So there is not one definition that can describe everything that it encompasses. So take 10 more seconds to think about what networking means to you, put it in the chat, and we'll move on. So Bella says, meeting new people and more opportunities. That's awesome. Keep it going. Using every opportunity available to improve our contacts. Very, very true. Learning new things. Absolutely. Broadening our vision. This is perfect. Keep it coming. I'm not going to be able to read all of them, but what I will say is networking is where you build your relationships, your career, where you take advantage of the opportunities you're given to make contacts, especially using the internet. You join communities and can find success in making connections with people who have a lot of common interests. And all of this can start by attending a simple meet and greet or a conference. So in this graphic, you'll see that everything I've just mentioned is separated into branches coming off of network. It really looks more like this, or maybe even like this, but it will most definitely not be as organized as this because everything leans into each other. It is not just career, it is not just connections. You can get your career by making connections, right? So if we did have to break this down, you can break it down into 3 parts. Organizations. Note that campus, academic, charitable, or national organizations will give you something different. New connections and new experiences that each other won't be able to give. So make sure to participate in all of them when you have the opportunity to varying extents. Then there are events, just like the one that you're in. We have a whole bunch of youth and guest speakers, but what differentiates you from all of your peers is that you've taken the time to come to this event. Either all of you can text me after this conference and say, hey, my name is so-and-so, and I saw you speak at today's conference. Boom, that's a connection, and don't underestimate the value of that. Now, perception is everything. So make sure that you've done everything you can to display your skills well, whether that's through a personal website or an all-inclusive social media account where you not only show that you love to bike, but you're also very passionate about giving back to your community. People will perceive you through what they see. So make sure you have what you want people to see on social media. But as I mentioned earlier, networking is fluid and cannot be defined by a series of words because it encompasses much more than what we can define. This is one of my favorite quotes of all time, and I'm going to read it out, but I really want you guys to think deeply about its meaning. No one lives long enough to learn everything. They need to learn starting from scratch. To be successful, we absolutely, positively have to find people who have already paid the price to learn the things that we need to learn in order to achieve our goals. Essentially, what it's trying to say is that if I want to learn something, I could very well spend 25 years of my life learning to be the very best at it. But if I want to do something else and I need that knowledge, I'd rather go to someone who spent their life being the best at what they can and learn from them and implement it into my goals. But that's it on my end. Thank you for listening. I hope you guys learned something. Here's my contact information if you want to reach out. I really, really love getting to interact with all of you, so please don't hesitate. And Daniel, unless you have any last comments, we'd love to take questions.
No, we're good. Thank you, Mansi, for that wonderful presentation.
So any comments, any questions, please put them in the chat. It can be about our experiences, about our presentation, or anything of the sort.
Does everyone here like Python or what? I guess, sure, why not?
I'm not too much of an engineering person myself, but I can say I've learned more about engineering today than I probably ever would have. So
there.
Can you explain what Key Club does? With pleasure. I'll keep it short because if you get me started, I'll go on for years. But Key Club is a student-led volunteering service parented by Kiwanis International. Essentially, we're clubs just like Student Council, just like the Environmental Club at school, but we focus through community service. What differentiates us is that we have a sort of hierarchy, if you will. We start off at clubs in schools, but a whole bunch of clubs make a division, a whole bunch of divisions make a district, a whole bunch of districts makes Key Club International. We're in 38 countries. We have over 270,000 Key Clubbers. And if you'd like to start one, DM me. I'll get you started. But a lot of volunteering, in essence.
So I guess we're going to now move on to our much awaited raffle. So we'll give the screen back to Ben.
I'd actually like to go ahead and give that screen to John, who should be getting that raffle pulled up. There we go.
All right, everybody who registered into the raffle, just so you know, for some people that weren't here, that did sign up and etc., they followed the post. Those of you who aren't here, were not actually eligible for the giveaway. You'd have to be in the call. So for the people that are here, congratulations, you are eligible to win the raffle. And as you can see, we have a randomizer on Google. It's not rigged. There's nothing, there's no, nobody has any favors. So might as well just get right into it. And congratulations, Isabel Yang. You won the $50 Amazon gift card. So me and Bella will get in contact with you via your email, and we'll get those things sorted right away. But other than that, thank you everybody who signed up and joined us today in the conference.
So Ben, we do have a couple of special things at the end. So can we get that up and going? So we would just like to give a special thanks to the Star of Life Project for making this possible. They are the organization that we are working with. And yeah, some special thanks to them. On another note, if any participants are interested in being an ambassador for youth STEM business conferences at your school and helping promote our work in your school, please feel free to DM us on Instagram, send us an email, or let us know, because we're always looking for more ways to help bring opportunities to youth. And we would love to have you guys on board for this wonderful experience.
And if you right now, if you want to check us out for our next conference, our next slide will show us our website as well as a QR code if you are watching on a computer, so you can scan it with your phone, check out our website. We'll keep it updated, and we'll also keep our Instagram updated at YSB Ottawa, so that you guys will get the latest information on our upcoming conference, which is about medicine. Thank you everyone for coming.
Yes, thank you everyone. We do ask one thing. We do want to take like a big group picture to show everyone how we do. So if you guys are okay with that, we would love to have you guys show us your beautiful faces for that. So I don't know, maybe Mansi or one of our team members would be able to get a grid view going, and we can just take a picture of everyone here. Ben, maybe you want to stop sharing the screen. We will be posting on Instagram, so you guys will have access to the recording of this meeting. We will send this out to people. If you guys want to see, it'll be on our website, everything. So let's get everyone here together for this wonderful picture.
I'll take a few, so bear with me, but where have you guys been?
Yeah.
No, it's good to see you.
Smiling faces, everyone.
All right, on 3. 1, 2, 3. Okay, that's 1. We're gonna go to the next page because we have 51 people here, so we want to make sure that everyone's in this. One more time. All right, 3, 2, 1. Perfect. Thank you so much, everyone.